Here we can look at some of the fundamentals of Lagoa. I've changed the layout appropriately here, and I'm going to just go to the volume emission. It asks me to pick my collision object, which will be my egg timer. It's going to build the graph for me. Now, I'm just going to hide my emission object, and there we go. We can see the graph it's built, and it's the three main areas we're going to be looking at are the physical properties of the Lagoa material, the actual emission, and the multi-physics simulation object, like substeps and things. So when I press play, first thing we notice is my collisions are wrong. So I've asked for front face, and I need to be back face because I'm inside this volume. So there we go. So now automatically it's grabbing the gravity and pushing it through from sun. I'm going to look at the emission properties. So here the resolution of each particle is 1 unit in size, and we're emitting just one set frame based on the volume of my original emission. So let's go to the material properties, because this is where it's all going to be happening. You notice the check boxes. Here we're dealing with pressure settings. Now this is really key to a lot of the Lagoa simulations that we're going to be seeing. If I were to take this off, let's have a look what happens. There's no pressure happening on any of these particles, therefore they just all go on top of one another. I'm actually going to reduce these settings a bit and ease them in. Let's just have a look at that again. So now we have some surface tension. Now, surface tension can be imagined like a liquid, sort of a cling film around the liquid. And the more surface tension we have, the more it's going to tightly pack the liquid. The less we have, it's going to try and go back to its original volume. We'll see the internal pressure of the simulation means that more internal pressure is pushing outwards, and therefore I've got no surface tension, so it's going to try and go to its original volume. The more surface tension I add, the more the sort of the shrink wrapping effect is going to take place. So it's a balance between the external pressure and the internal pressure together with the surface tension here. The boundary pressures, that's really to do with the collision objects, and the internal interface pressure is to do with the collisions in between each particle. So that's dealing with the basic pressure settings. Let's go on to the next one, which is the inelastic settings. Let's just turn this one off and turn this one on. Let's see what happens. So inelastic is not elastic, kind of means rigid. So you can now see it's a lot more like a rigid body dynamic simulation here, and see how they bounce off each other. Now the inelastic collisions, if I were to reduce that, kind of the same thing as the surface tension. There's no intercollision inside each of these rigid elements. But as if I play this back again, once it goes through, if I add that inelastic collision again, it goes to try and go back to its original shape, because each of those are intercolliding. You see how it's jittering there. I have a way I can just add the number of substeps to stop that. And I'm just going to keep it low just for now, because I want to see the interaction. So let's go back to the material, and we're dealing now with the inelastic collisions. And the friction flow rate is, again, for like the interparticle and whether or not they rest on top of each other. So inelastic friction, do they stick on top of each other? The inelastic collision, when they collide. Now remember, we are dealing with this material collision offset. If I were to reduce that, then things like you notice they're not quite sitting on the surface here. That's because I've added this offset. Now we can see if I were to dial that in, it's going to push them off my collision object. So I'm dealing with certain collision properties here. And surface friction, if I had no surface friction, they'll really skate around on the collision. But if I add a whole load, when they hit, they'll stick, and that also will control the jittering. But you notice how it also will stop a lot of the funneling effect, because it's trying to stick to this, it's trying to collide with it, and they're trying to do intercollision. So here we're starting to see how we can balance the settings to get the right flow. I mean, we're dealing with, originally was just a basic flow, and now we're kind of dealing with a more granular effect with inelastic settings. Now if I go and have a look at the elastic settings, let's see what we've got here. Well, it's elastic. It's like a blob of jello in this case. I can obviously play around with the elasticity. That becomes more like a paste there. A couple of key elements in the elasticity are the shearing. If I were to reduce that but still keep it elastic, let's have a look. So now it allows it to shear. I'll reduce this slightly, reduce the breaking point. It still has some elasticity, but I've allowed it to stretch and shear at the same time. I can also reduce a bit of the damping. So with the elasticity, let's go with that again. So I've made it a bit more elastic, and you see again I'm going to try and push back towards some of its original volume after the effect. So I'm just messing with it a bit there. So these are, if I were to actually go back and look at the pressure settings, these are the main elements. So with the elasticity, if I was just to reduce the shearing again and the elasticity settings, I'm still now dealing with the pressure. So here the surface tension, the internal pressure. So it's pushing outwards, and that's why it's not dripping through. If I have no pressure, it's going to start to drip through. So we've got some elasticity. If I reduce that, turn off the shearing completely, as well as the breaking point, and I'll see that it's going to be a lot easier for it to funnel through. So the pressure is the backbone of Lagoa. So doesn't have quite the same effect with the inelastic, but certainly it has a profound effect on a lot of the Lagoa settings. So when we start to grab some of the Lagoa material types, let's say we go and get the granular and have a look at that, you notice it's really dealing with the inelastic settings. So each of the components can be broken down, whereas the main material has all of these optional in one go. So that's really a quick overview of the settings of the main material and how they interact with each other.